Okay, this is the next question. We're gonna start off with the number 4 for this video. Write down the order of rational symmetry of a regular hexagon. Do you guys remember what rational symmetry means? So, okay, look. If I rotate the shape of the regular hexagon, this is the hexagon by the way, yes. If we rotate the shape, how many times will it look exactly the same before I get back to where I started? So, now if we look at the regular hexagon, what did we remember? This is the regular hexagon, right? It has equal of 1, 2, 3, 4, 5, 6. 6 sides. So if I turn it 60 degree or 360 degree, it will have the same shape. By that means, we can say that it matches itself 6 times during one full turn. So thanks to that, we're gonna write 6 over here. That's a very big 6. Let's read the remaining information. The shape is made from a regular hexagon and a square. The vertices of the square lie on the sides of the hexagon, which is true. Let's see if it's true. Sorry, these are the vertices of the square and they do lie on the side of the hexagon. So they're asking, for this shape, write down the number of lines of symmetry. Okay, so this is actually the part students often rush. The shape is not just a hexagon anymore. It is both a hexagon and a square, which are joined together to form one shape. So every symmetry line must work for both. Imagine drawing a line straight down the middle, like this. Now pretend you're folding the shape along that line. So we have one line of symmetry, but if we fold this here, it will have the same shape, if you know what I mean. Let's use our imagination for this. So we have one line of symmetry, okay? Now let's check the horizontal line. Since we checked the vertical line first, let's check the horizontal line. Let's draw a line through the center from like horizontally like this. Okay. Now let's fold it. If we fold this part like up to here, we will see that the top will land on the bottom and will be equally shaped. So we have another line of symmetry, which means we have two lines. The answer would be 2. Okay, I hope this information helped. Okay, so let's read out the question before we solve it. Using ruler and compasses only and showing all your construction lines, construct the perpendicular bisector of AB. Before we solve it, let's remember what perpendicular and bisector means. Perpendicular makes a 90-degree angle. Bisector cuts something exactly in half. So joining them both the definition together, we can tell a perpendicular bisector is a line that cuts AB exactly in the middle and crosses it at 90 degrees. So we're gonna remove this right here to add more space. So first step, we're gonna open, since I cannot really show the entire process, I'm just going to help you guys imagine how to do it. And I expect you guys to use a real compass and ruler to practice and do it as I explain the process to you. So first step, we're going to open the compass to more than half of the length of AB. More than half would be like this, or like whatever, approximately. You may ask why more than half, because we need the arcs from A and B to meet. If you only use half or less, they won't cross. Without changing the compass, we will need the pointy to be here. Honestly, you know how this works, and the pencil part, obviously you're gonna measure. You're not gonna draw anything, you're just gonna measure more than half. So without changing the compass, with draw an arc from AB. It's like this. You're gonna take one here, and then you're gonna draw like this. It's gonna be above AB, then you're gonna take it downwards, and you're gonna be below. So it's gonna be like this. Then you're gonna move the compass, the pointy thing here, and draw another arc above and below. So the same width, by the way, it's gonna be like this. Honestly, for my own good, I'm gonna write it correctly. This, this, and this. Okay. So now you see the arcs intersect. Now you're gonna take a scale and join the intersection like this. It's gonna, well, it was perfect. Now this vertical line that you see is the perpendicular bisector. This is the next question. The bearing of point P from point Q is 304 degrees. Calculate the bearing of point Q from point P. Okay, that's nice. Since it's 2 marks, we can just do it an easy way. There's this information that I always used to like for these easy questions. If the given bearing is less than 180, add 180. If the given bearing is 180 or more, subtract 180. From this information, we can say that the given bearing is definitely greater than 180, so we're going to subtract 180 from the given bearing, which gives us the answer 124. Perfect. Find the value of this, we're not going to obviously read it, this when P equal to and Q equal minus 5. Okay, nice. For this, we're just going to place the values in the correct order and we will put it in the calculator and we're going to find the answer. 2 times minus 5 minus 3 minus 5 square entirely divided by 2p plus 2p plus 1. If we put it in the calculator, we get the value of minus 17. Nice. Minus 17. That's it. This question is saying, given that y equal this, find dy by dx. They're telling us to differentiate the given equation for y. Dy by dx, 3 will go in the front because it's the power. Then 3 minus 1 plus 2 times 2 as it goes in the front. Then 2 minus 1 minus 15 times 1 as it has just 1 as its power, the x, however the x will be 1 minus 1 minus 1 plus 7 times 0. You can just do it in one step actually, but I'm just showing just in case anyone doesn't know how to solve it. I'm guessing everyone does, whatever. Minus 15 plus 0. So the answer will be 3x squared plus 4x minus 15. That's it.